A very good morning to all of you. This might seem a little bit like a vendor-based presentation, but I trust hopefully I'll try and make it a more academic style presentation. Let me get the clicker right. Yep. So I'm going to try and talk to you about machine learning trends in cybersecurity. I'd like to give you a few use cases. And I'd like to talk about a few practice recommendations, right? So it might be a little bit of a fluffy talk, not as deep as what you've just heard Jason talk about, but I hope there are some important takeaways from this presentation. So it's important to present some complementary statistics, right? You have to have these nice visual stats, but things are getting really serious out there, right? So we see that ransomware attacks are getting quite frequent. We see apparently the Homeland Security estimates that $350 million was paid out for ransomware attacks in I think last year. And the expectation is in the next 5 years, we might be, attacks might be accumulating, might cost us about $10.5 trillion, right? So because this was geared towards SMEs, I did throw in stats on the SME side of things, but SMEs are trying to get into this space. I think there is a major challenge here for SMEs, for even regular enterprises, because when you look at the recent list of companies being hacked or breached, Tesla and there's lots of big stars among those companies. So when you think about that, for SMEs, you can see that it's even a harder challenge to deal with it. Let's talk about machine learning, right? So I kind of assumed that not everyone has done much on machine learning, but essentially machine learning, from how I understand it, is an automation of human learning to a certain extent, right? So we basically give an algorithm some pre-labeled data, and it goes through this data just like how I would learn the difference between parrots and crows after looking at lots of examples, and then it comes up with a model that then helps you predict the difference between a parrot or a crow, right? And then on the other hand, a related kind of learning, which we call as unsupervised learning, is about a situation. I give this example to my students. Assume you were walking into a forest and you just saw 3 kinds of fruits. You saw a banana, you saw an orange, and you saw an apple, but you didn't know what they were called, right? So when you come out of this forest, and if I asked you, what did you observe, or what did you find any interesting groups of things? You would probably, people might suggest that they found 3 groups of things based on the features of the 3 different fruits, and then you would label them, right? And you would give them a name, and then you would say, then that becomes your data set for training or for training other machine learning algorithms to actually come up with a model to classify, the differences between an apple, a banana, or an orange, right? So machine learning is, as I said, it mimics human learning in that sense. And when we talk about machine learning and cybersecurity, I think the most common application of machine learning is to actually go through a large amount of data related to your networks, which could include log data, could include data from your endpoints, from your devices, from the behavior of users on the network, and trying to basically dig through these volumes of data, come up with a predictive model that tells you when something doesn't seem right. So when is an event happening that's not normal, right? So most of the machine learning applications in cyber are towards that goal, that you basically dig through large volumes of data and you want to try and come up with something that doesn't look right? And then predict that and then protect yourself against that. So the traditional models used to be called as signature-based approaches, where you had identified certain patterns of bad behavior, and that was kind of programmed and then try and detect it, right? But what we're seeing with machine learning is pretty much a constant dynamic learning environment where models are being updated to understand newer threats that are coming up. Right? So, for example, if you take ransomware, right? Ransomware often targets applications, right? So, how do you know when an application isn't behaving, in a proper manner, right? You might have to look at the stack trace. You might have to look at the functioning of the application in your memory. study the stack and see if there's some code being injected or some malicious code being injected into the stack, right? So and how do you then build a machine learning algorithm to do that? So you'd have a machine learning algorithm try to look at large volumes of exemplar stack traces and then try and identify if something didn't look clear, right? So this is really the common trend with using machine learning algorithms. So as I promised, I've got 5 use cases where I see machine learning algorithms in action at the moment. Intrusion detection is by far the most common machine learning application, right? We see large numbers of algorithms of various kinds being applied to intrusion detection, which pretty much means collecting, as I said, large volumes of data from your network, analyzing them, trying to identify if something is not right. Yeah. There are some assumptions for this, though. The assumption is that you can observe system activities, and normal and intrusive activities have distinct signatures, right? And so that's why when someone is able to smartly couch an abnormal activity as a normal one, your machine learning algorithms are going to struggle, right? So, responsible users, I guess, behave in a predictable manner. That's the assumption, and that's what is used. But in terms of typical goals for intrusion systems, we have some issues that I think are really important. I'll draw upon these issues again, but we want to try and minimize false alarms for sure, right? We have a limited number of security professionals working in companies. They can't be spending all their day analyzing and trying to responding to every other alarm on the network, right? So you need to restrict or reduce the amount of false positives. You need to monitor diverse data sources. So I'm going to just talk about that in the next one, which is endpoint security. Now that we're all on Zoom and we're working on devices at home, endpoint security becomes even more, kind of important, right? We're accessing private data through our personal devices, and so the classified data. So the issue is, how do you ensure that your endpoints are safe, your devices are safe, and all these other data storage and cloud hosting environments are safe, right? So there are several. I guess I'm talking about vendors, but I'm not working for a vendor. But there are several solutions already out there that actually use machine learning algorithms to try and kind of do the same thing. What do I mean by that? This is one example, right? So I don't work for Mobile Iron, but this is a typical approach that is taken, right? So what happens is you collect a large volume of data, and that could, what this data is nothing but important attributes from all your endpoints, the devices that you have curated and picked up, right? So these attributes become your data set, right? And then what happens is you go through a behavior characterization from the data. In order to do behavior characterization, you could apply unsupervised learning techniques. For example, you can try and cluster all your data into activities that may be normal, maybe not normal. You could have a distribution of activities in a various sort of, I guess, in a probabilistic sense, right? You could do that. But once you characterize them, then you could do some kind of training. That is, you could create a data set where you label some of those activities as normal, some of them as abnormal, and then you can start creating an ML, a machine learning model, and then that model is then used to protect your devices and the endpoints, right? So that's a typical use case for endpoint security. Again, machine learning seems to be quite common. Threat intelligence is another big area, detecting threats upfront and then responding to them. The challenge, this is one of the big areas, because what we are seeing today is we're seeing a very dangerous threat landscape. It's not just individual criminals who are working on this. It's state actors who are working on this. So the issue is that how do you basically detect threats in time so you can respond, right? So again, we can actually consider the same machine learning principle application. Integrate looking at your existing solutions, which can be your network detection and response solutions, your SIEM solutions. You could collect all of the data, relevant data, both structured and unstructured data from disparate sources, and then you can try and connect the dots, learn models based on indicators and other attributes, right? So This is a really nice paper that I read from MIT's CSIRO lab. It's called the AI squared system, and pretty much what it has done. I won't go through the process. It's very similar. So both supervised and unsupervised learning coming together to create like a defense system for detection. And the system was able to, the great thing about the system, it's touted as a big data system. So it was actually able to throw through millions of logins, for example, and pass it to a human analyst, reducing alerts to around 100 a day, right? So an attack detection rate rose to about 85% with a 5-fold decrease in false positives. So it's a very interesting system. Finally, 2 use cases. Just checking for time. Yeah. Security, automation, and zero-day vulnerability. So zero-day exploits, right? So put simply, I mean, a zero-day exploit is something that you haven't figured out is wrong and is not been patched up in your system. So you haven't patched it. So someone finds out before you do, and they kind of like mess your system up, and then they take over and do all kinds of bad stuff, right? So patching is really important here, and not everyone knows that they have to patch. I mean, many people still use Windows 6 or sorry, Windows 7 or XP. Lots of old systems around. Internet Explorer is still around, and so the role of automation here is basically thinking about how can you automate tasks that security ops teams are constantly engaged in, because then they can look at the more abnormal aspects that can actually destroy your network or do something really bad, or can actually encrypt your data on a ransomware attack, right? So lots of ML applications, AI and ML automation applications, which are around that are able to kind of automate repetitive tasks and then give security engineers time to look at the more outlying cases, right? So there's a nice system that so Darktrace is a vendor that actually is among the leading AI-based security vendors. I don't work for Darktrace again, so but it is I like their platform called the Enterprise Immune System, and what it kind of, I guess the idea there, I like the concept in a sense that for you to have really good intelligence, threat intelligence, and the entire, I guess, the end-to-end loop and solution, I think what you need to have is you need to have a real-time sense of what is happening, not just on your network, but on your endpoint devices, on every single piece of data that you can actually, that moves through your enterprise, right? If you can have a system that's sensing everything in real time, then you could have something, a system like this, which basically is in real time capturing data, trying to interpret it, trying to send the right alerts to staff, trying to then look at machine learning to look at those aspects that can be predicted, right? And then provide a visualization of the threats in real time for you to respond. And this can be integrated with your security information and event management system, can be accessed through other APIs and connected to other, I guess, devices. So, in terms of zero-day vulnerabilities, there's an interesting case, and this is something that you could think about as an ML application, is how can you try and identify zero-day exploits by looking at information being posted on the darknet or deepnet kind of, the anonymous internet, right? So can you run sentiment analysis or even like natural language processing analysis and apply machine learning models? Sorry, I'm just going to finish in a minute, but this is something that Arizona State University has done. I'm going to wrap up with just a few challenges and then I'll end. It is still not a magic bullet. So machine learning is really not going to solve everything for you, right? There's a heavy level of human augmentation that's needed for successful applications of machine learning. The biggest challenge, because I come from the data analytics part, it's all about the data, folks. I mean, if you only have garbage, you're only going to get a model that they basically can't predict. So you've got to put all your efforts on the data, ensuring that you've got quantity and quality of data from your, I guess, relevant to your network defenses, right? And And then not just that, remember, machine learning is compute intense. So basically, to basically go through large volumes of data, it's going to require infrastructure. So typically, a cloud-based system, most machine learning, most big data systems usually are supported by some cloud infrastructure. And so the machine learning is actually done on the cloud. The models are then downloaded to the endpoints and implement and deployed, right? So the learning, so there's always that cloud end, or you need to invest in heavy infrastructure in order to be able to do that, to come up with these good models, right? Finally, I'll finish up with one interesting thing that I read. Two interesting things. One, I saw a Tom Cruise video, which was really good, deepfake, in the news today. So apparently that defeated all the deepfake detection technologies as well. So it's in the news today, so might want to have a look. And the other thing that I read was about this thing called Deep Slot. It's a program, or it's a software that's been designed to defeat machine learning based detection. So what it actually does is it slows down your detection to a point where it takes about 15 times longer for you to develop models, and basically clogs up your cloud infrastructure by, I guess, I don't know how they do it, but this is something. So there are challenges for deep learning based defense, cyber defense, ML applications as well. So there are some smart criminals out there. So and ransomware kits are also quite cheap. So be careful that you have to be aware of all these things while you design and develop your cyber defenses. Thanks, everyone.